Hey guys, welcome back. Today we will see about thread groups in Java. So thread group is actually a class in Java which is used for creating a group of threads. So this group of threads are actually in a form of a tree structure. So the first node in the tree is actually the parent thread, and if required we can create n number of parents, or we can create a tree with a single parent and many subchilds. So thread can have all the information of the other threads in the same group, so that's always possible. But in the same manner, the thread cannot hold information about any other group. So whatever information that surrounds the single group will be available to all the threads inside that group, but not outside that group. So that's what we have to understand here. Then it's very useful in the case when we want to suspend a group of threads. So let's say you have a group of threads working on the same problem, and at one point of time you want to suspend, or you want to release, or you want to finally terminate a group of threads. It's always possible. In the other case, if we have single threads without any groups, then we have to pick out or select all the threads, separate threads, and then we have to find a mechanism to delete them altogether. But using a thread group will always be useful in this scenario for us. So this thread group is actually implemented by the thread group class, which is present inside the lang package. And there are two type of constructors for the thread group. So when we create a thread group, we have to make sure that we have to call these constructors in order to make a thread as a member of a group. So the first constructor what we have seen here is thread group with a single parameter. So you just pass in the name of that group, that's more than enough. And the second constructor what you see here is really useful when you are creating a tree, or no kind of a parent child relationship in the thread group. So you can create a single parent group, and further groups can be made as the child of this group. So for this requirement we will be using the second constructor. So with this information, let's go and see a program how to create a group. So in order to create a group, first of all we need a class. So let me create a main class. Let me call this class as demo. So let's have the main function here, main method, static void main. And since we are using multi-threading, so we can expect interrupted exception to be thrown. So we'll make sure that we capture that and handle it properly. Apart from this, we need a class which extends the thread class. So let me call it as tg or tgrp. So let this class extend the main thread class so that it can do multi-threading. And of course we need a constructor for this class so that it calls the super constructor of the base class. And also we need a run method which will execute once we call the start method. So let's start creating a simple thread group. So in order to create a thread group, you need to use the thread group class, and let's say we create an object like this, is equal to new thread group. And this is the first constructor I'm going to use, and inside this you can pass the parameter as a name, which can be the group name. So let me call this as parent group, or some other name, group 1 or whatever you wish. And let's say we create a thread now. So thread group t is equal to new rp. And while we are creating a group, we have to pass in, while we are creating a thread and we want to assign that thread to a group, we have to pass in the group name. So the recently created thread group is given by g1, followed by this corresponding thread's name. So this corresponding thread, let me call it as thread 1, or let me call it as user thread 1. That means a lot. So user thread 1 is the name given to this thread t, and it belongs to the group g1. So when this is created, automatically the constructor will be called upon. So we need a parameterized constructor here. So let me use that. So first of all, I'm passing a thread group object. So let me put it like hobby, comma, and then I'm just passing the thread name. So let me call it as the name. So here we have to pass this information to the superclasses constructor so that the thread group gets registered in the thread class. So I'm going to pass in object. So when I call this constructor, G1 will be passed to OB and OB is passed to the super constructor. So obviously OB will be a new group that is registered under the thread class. And also one of the threads that are into this group G1 is the user thread 1. So I'm just passing that name also. Okay, so hope it is clear. Now inside your run function we can have some try catch mechanism. I'll be capturing the interrupted exception. So let's print the stack trace. This will just print the error statement as such. And let's say that okay, let this thread sleep for like 2 seconds. Yeah, that will do. Maybe I'll put a small print statement. I will print the thread's name. Maybe so this will do, I guess. So let's save this and let's call this start method so that the thread is started. Maybe if you want, we can even print the group's name. So this get name function is common for the threads as well as the thread group. So it will even print the thread group's name for us. So let me call this g1.getName. Hope it will print the name for us once after it finishes execution of that statement. If you want, you can print this for 3 times. Let's say 0, I less than 3, I plus plus. So this statement will be printed for 3 times and it goes into sleep mode for 2 seconds. So after completing this iteration, let's print the completion of execution. Okay, so I think this will do. Let's try executing this code. Okay, did I mention the file name wrong? Yeah, it is th demo. Okay, let's change the name. Fine, let's go for execution. The compilation is fine. As you can see, the user thread 1 is executing. The group name is parent group. Then again it goes back to the user thread 1, and once it completes execution of that, it will come out of the whole program. So this group name is the parent group and the thread T1 or thread 1 belongs to that group. So in a similar fashion, we can even create another group under the same parent. So what we do is I can create another group in a similar fashion. So this time I'll be using the second constructor what you have seen. So let me call this as child group, which has to come under that parent. So this time when you create a group, so we will create a group in such a way that we first pass the first parameter as the first group's name. So in such a manner, this group G2 becomes the child group of G1. So it follows the tree-like structure. Now after this, we can create an object. Let's create another object T2. So it means we are creating another thread, and let this thread be a member of the second group. So it's a thread 2. Okay. So even when you call this constructor, so it will be registered with the name G2, but G2 is again indirectly connected to G1 in a parent-child relationship. And let's execute this method start so that we can start that thread also. And also if you want, we can print the thread group's name again. As you can see, the first thread group was parent and then the child group, then thread 2 is executing, thread 1 is executing, and once after the final execution, the total program terminates. So hope it is clear. What we have seen in this session is about creating thread groups. So thread groups are a group of threads which are acting on a same job. So the advantage of this thread group is that we can assign different small roles for every thread, and every thread can be a part of a group. So deleting all the threads or assigning jobs to the thread or finding the priorities of the thread will be really easy for us if they are in a group. And let's go back to the presentation. We have certain other methods which belongs to this thread group class. So as you can see in the slide, we have the check access, active count or active group count, or destroy. So this method destroy is really useful. It will help you to terminate all the threads inside a single group with a single command. And then we have get max priority, so that's another function. And get name, get parent name, that's also useful. Even you can go for setting the maximum priority, because this will be really useful when you are handling threads in a group. So when you set a maximum priority for a thread group, even if you assign certain threads which are exceeding that priority to that group, the thread automatically goes down in the priority level. So let's say you set a maximum priority of 5 for a thread group, and you want to insert a thread with a priority 10 inside that group. When you insert it, automatically the priority of this thread will be pulled down to 5, because the maximum priority that is supposed to be for a thread group is 5. So that's the understanding here. It will be really useful. And then we have certain other functions. We can even create daemon groups. We already introduced a daemon concept for you, and we can even check whether a group is daemon or not, or we can even check whether the group is currently live or whether it has been destroyed. And we can suspend a whole group, as I mentioned earlier. Like suspending and resuming a whole group of threads is difficult task when they are separated. Now if they are in a single group, when we can just call the group's name and we suspend them, as well as we can resume whenever required. And if you want, we can permanently stop the groups. So being said, this is all about thread groups. If you have any queries, please feel free to comment on the comment section. We're always ready to answer your queries. So thank you for your time. I'll see you in the next video.